we have two more sets, set 2 and set 3. But there are some questions which are different in set 2 and set 3. So we will do only that questions. We will do only those questions which are different. So let us start. Question number 9 is different in set 2. Evaluate cos inverse sin x dx. We can write sin of x as cos 90 minus theta is sin theta. So here we have x. So cos pi by 2 minus x. Cos inverse and cos will get cancelled. Pi by 2 minus x dx. Pi by 2 is constant. Integral of 1. Integral of x is x square by 2 plus c. Next question is question number 10 is different. If the vectors a vector and b vector are such that magnitude of vector a is 3, magnitude of vector b is 2 by 3, and a cross b is a unit vector, then write the angle between a and b. It is given that a cross b is unit vector. We know the formula for a cross b, that is equals to magnitude of a, magnitude of b, sine of theta. We have value of magnitude of a, b, and we want to find the angle between a and b. So 1 by 2. 1 by 2 is the value of sine 30 degree, sine pi by 6. So we get theta as pi by 6. Note up to here. Now the next one is question number 19 is different. Write down the statement for question number 19. Prove that following using properties of determinant a plus b plus 2c, c, c, a, b plus c plus 2a, b, b, c plus a plus 2b is equals to 2a plus b plus c whole cube. We will have to prove this by using the properties of the determinant. Now first operate, we want 2. So add column 1, 2 and 3. A plus A, 2A, B plus B, 2B and 2C is here. C, B plus B, 2B, C plus C, 2C. And similarly here A, B plus C plus 2A, A, B, B, C plus A plus 2B. Now take this common from the column 1, 2, A plus B plus C, 1, 1, 1, A, B plus C plus 2A, B, B, C plus A plus 2B. Now in the determinant we have to make maximum number of zeros. So operate R1 as R1 minus R2 and R2 as operate R1 as R1 minus R2 and then on second R2 as R2 minus R3. So 2a plus b plus c r1 minus r2, a minus 2a minus a minus b minus c and b minus b. R2 minus R3, 1 minus 1, b plus c, 2a minus a, b minus c minus a minus 2b, 1a c plus a plus 2b. Now from here we can take a plus b plus c common from R1, and from R2 we can also take C1 plus C, A plus B plus C common. So here we are left with 0, 1, minus 1, 1A, C plus A plus 2B. 2A plus B plus C whole cube. Now expand it along the first column. First two terms are 0 plus 1 into minus 1, 1, 0, minus 1. 2a plus b plus c whole cube plus 1 minus 0. 1 minus 0 is 1. So we get 2 times a plus b plus c whole cube. Now the next question is, which is different, is question number 20. Differentiate tan inverse x upon square root of 1 minus x square with respect to sin inverse 2x 1 minus x square square root. Let this as y and this as z. Now put x is equals to sin theta. So y is tan inverse sin square root of 1 minus sin square. Use the identity here. 1 minus sin square is cos square and square root of cos square is cos. Sin upon cos is tan. So we get the value of y as theta. Here put x is equals to sin theta. Z is sin inverse 2 sin theta square root of 1 minus sin square. Sin inverse 2 sin theta 1 minus sin square is cos square and square root of cos square is cos. 2 sin theta cos theta, that is equals to sin 2 theta. Sin inverse and sin will get cancelled. Here we are left with 2 theta. Now dz upon d theta 2 and dy upon d theta is 1. Differentiation of theta with respect to theta is 1. Now we want to find derivative of y with respect to z. So that is equals to dy upon d theta upon dz. We can write it as this. So dy upon d theta has value 1. 1 upon dz upon d theta 2. So the answer is 1 by 2. Now the next one. Solve the following differential equation. Cosec x log y dy upon dx plus x square y square is equals to 0. First, we will write it as cosec x log y dy upon dx is equals to minus x square y square. Log y upon y square dy minus x square cosec x upon cosec x dx. We can write it as log y into y power minus 2. Cosec is 1 upon sine, so minus x square sine x dx. Integrate both sides. Elate logarithmic as first, algebraic as second, trigonometric as second. First function as it is integral of second. Integral of y power minus 2 minus integral के अंदर डेरिवेटिव ऑफ फर्स्ट, इंटेग्रल ऑफ सेकंड, इंटेग्रल ऑफ फर्स्ट फंक्शन एज इट इज, इंटेग्रल ऑफ सेकंड माइनस डेरिवेटिव ऑफ फर्स्ट, इंटेग्रल ऑफ सेकंड. So we get the result as log y, integral of x power n is x power n plus 1, minus 2 plus 1 is minus 1. Derivative of log y, 1 upon y, y minus 1 upon minus 1 dy. Integral of sine is minus cos of x. Derivative of x square 2x. Integral of sine is minus cos. Is it clear up to here? Now minus log y upon y, minus minus plus 1 upon y square, x square cos of x minus 2 x cos of x. Now again first function and second function. Minus log y upon y, y minus 1 upon minus 1, x square cos of x minus 2. First function as it is, integral of cos is sine, minus derivative of first, x is 1, integration of cos is sine. Minus log y upon y, minus 1 upon y, x square cos x minus 2x sin x, minus minus plus 2, integral of sine is minus cos x plus constant of integration, say c. Now the next one is question number 22. Show that the lines 5 minus x upon minus 4, 5 minus x upon minus 4, y minus 7 by 4, z plus 3 upon minus 5, x minus 8 by 7, 2y minus 8 upon 2, z minus 5 by 3 are coplanar. First, the line of the equation in the Cartesian form is x minus x1 upon a. So we will have to compare this. So x minus x1, so take negative common from here. So we get it as this, y minus y1, z minus z1. This is also written as 2 taking 2 common, z minus 5 by 3. Now from here x1, y1, z1, a1, b1 and c1, x2, 8, y2, 4, z2, 5. A 1 and C2 3. So we get the value of x1 5, 7 minus 3, a1, b1, c1 4, 4, 5, 8, 4, 5, 7, 1 and 3. Now x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2. Now we have to find the value of this. If this is equals to 0, then these lines are coplanar. So x2 minus x1, 8 minus 5, 4 minus 7, 5 minus minus plus 3, 4, 4 minus 5, 7, 1, 3. Now solve this. 3, 4 minus 5, 1, 3 minus minus plus 3, 4, 7 minus 5, 3 plus 8, 4, 7, 4, 1. 4 into 3 minus minus plus 4 into 3, 7 into 5, 4 into 1, 7 into 4. Multiply these terms. Minus 192 0. Therefore, the given lines are coplanar. Therefore, the given lines are coplanar. Now the next one. Next question which is different is question number 28. Evaluate the integral 0 to pi x tan x upon x tan x upon sec x cosec x dx. We can write tan as sin upon cos, x sin x upon cos of x, sec as 1 upon cos and cosec as 1 upon sin. Clear? Now cos of x will get cancelled, sin will go up and it becomes 0 to pi x sin square x dx. Now we will use the identity here 0 to a property. 0 to a f of x dx is equals to 0 to a f of a minus x dx. Use this property here 0 to a minus x. A is pi sin pi minus x square dx. Sin pi minus x in that quadrant, sin is positive. Sin is positive here, sin pi minus x. So 0 to pi, pi minus x, sin square x dx. Let this as interval, this as integral as I. Now add 1 and 2 equation. Let this as 1 and this as 2. Add 1 and 2. 2i is equals to sin square x common from both equations, x plus pi minus x dx 0 to pi. So pi 0 to pi sin square x. Sin square x के लिए हमारे पास डायरेक्ट कुछ भी फॉर्मूला नहीं है. We have formula cos 2x as 1 minus 2 sin square x. From here we can find the value of sin square x as 1 2x upon 2 dx. Clear? Now we will have to solve the equation. So I is pi by 2, integral of 1, integral of cos is sine 2x upon 2, limit goes from 0 to pi. So pi by 4, pi minus sine 2 pi by 2 minus lower limit is 0. Sine pi, 2 pi all have value 0. Sine 0 is also 0. So we get the answer as pi square by 4. I is pi square by 4. Now the next question, which is different in set 2, is question number 29. Prove that the semi-vertical angle of right circular cone. First we make the shape of cone. Right circular cone, let it is the radius, height, this is slant height. Right circular cone means it is making an angle 90 degree with the base. Right circular cone of given volume and least curved surface area is cot inverse square root of 2. We have to prove that semi-vertical angle of right circular cone of volume and least curved surface area is this. Write down, let radius of the cone is x, height of the cone as y. Now what is the volume of cone? 1 by 3 pi r square h. R is x and h is y. Now volume is constant, so let the volume is 1 by 3 pi k. Both are the volumes of cone, so they will be equal. 1 by 3 pi x square y. So k is x square y, or we can say that y is k upon x square. Now it is given that least curved surface area. What is the surface area of the cone? That is pi r l. L is square root of r square plus h square. R is x and height is y. Radius is x and this is square root of x square plus y square. Put the value of y here. Square root of y is y square k square upon x 4. Now if we squaring on both sides, we get as pi square x square plus k square upon x4, pi square x square x6 plus k square. So pi square x6 plus k square upon x square. For simplification, let s square as z. Now differentiate both sides with respect to x. Pi square x4 plus k square into x power minus 2. Now dz upon dx. Dz upon dx, pi square is constant, 4x cube, k square is constant, minus 2, x power n, derivative of that is n, x and minus 1. 4x cube plus k square, this. Now this is 4 pi square x cube minus 2 pi square k square x power minus 3. Now to find the points, we have to put the first derivative is equals to 0. So 4 pi square x cube is equals to this. Pi square will get cancelled. 2x cube is equals to k square upon x cube. k square is, we have the value of y as k upon x square. So k is x square y. So put the value of k, x square y upon x cube. So 2x6 is equals to xy square. So 2x5 is equals to y square. Here we have x cube. If there is x cube, 3 minus 1, 2. So we get the value of y as square root of 2 into x. Y as square root of 2 into x. Now to check whether it is the point of minima or maxima, we have to find the second derivative. So second derivative of this is equals to 4 into 3, 12 pi square x square minus 12 pi square x square minus 2 pi square k square is constant minus 3x minus 4. So 12 pi square x square minus minus plus 6 pi square k square upon x power 4. Now all these terms are positive, so we will get the result as positive. Since second derivative is positive, therefore z is minimum. Z is minimum at y is equals to square root of 2x. Z is minimum. अगर z minimum है, हमने z क्या माना था? s square. So s square is minimum at this. Now we have to find the angle. So curved surface area is least when x is equals to y upon root 2. Now let this triangle as AOB. In triangle AOB, if this is the angle theta, cot of theta is, tan is P upon B, so cot is reverse of tan, B upon B. This is perpendicular, so base is OA and perpendicular is OB. So cot of theta, OA is height y and OB is radius, हमने क्या माना था? x. Now put the value of y, square root of 2x. So theta is cot inverse square root of 2. इसके बाद क्या प्रूफ हो गया कि जो surface area है that is least when x is equals to y upon root 2. Now we want to find the semi-vertical angle and we want to prove that it is equals to cot inverse root 2. So take this triangle and cot is B upon P, base upon perpendicular. So we have OA height, we take it as y and radius as x. Now put the value of y there. So angle, semi-vertical angle theta is cot inverse root